Before you watch this video, kindly go and see our previous video on mole concept.
Let us see in this example with 1 gram of anhydrous calcium chloride. 1 gram of calcium chloride is converted into milligrams, which is equal to 1000 milligrams. We will use the formula for millimoles, which is equal to weight of the substance in milligrams divided by the molecular weight of the substance in milligrams. The total weight is around 1000 milligram. And the molecular weight of calcium chloride is 40, which is the atomic weight of calcium, plus 2 times the atomic weight of chlorine, since calcium chloride contains 1 calcium ion and 2 chloride ions. Now when we simplify this, we get a value of 9 millimoles. So 1 gram of calcium chloride is equal to 9 millimoles. We can see that 1 calcium chloride dissociates into 1 calcium and 2 chloride ions. 9 millimoles of calcium chloride will dissociate into 9 millimoles of calcium ions and 18 millimoles of chloride ions. We know milli-equivalent is equal to millimoles multiplied by the valence. So we convert the millimole values into milli-equivalent values by multiplying them with their respective valences. Now we get 9 milli-equivalent of calcium chloride is equal to 18 milli-equivalent of calcium ions and 18 milli-equivalent of chloride ions. Therefore, 1 gram of calcium chloride is equal to 9 millimoles. 9 millimoles of calcium chloride will give 9 millimoles of calcium ions and 18 millimoles of chloride ions. 9 milli-equivalents of calcium chloride will give 18 milli-equivalents of calcium ions and 18 milli-equivalent of chloride ions. We know milli-equivalent is equal to millimole into the valence. We can also write that as milli-equivalence is equal to weight by molecular weight into the valence. Now if we interchange their places, we can have this equation as weight is equal to milli-equivalent into molecular weight divided by the valence. Just interchange their places and we get the value of weight. Now we can use this formula. We know 9 milli-equivalents is equal to 1000 milligrams. Now we use the weight formula here to find how much does 18 milli-equivalent of calcium ions weigh. In the milli-equivalent part, we write 18, which we multiply by the molecular weight, and we divide it by the valency of calcium, which is 2. We get a value of 360 milligrams. Place the formula of weight. We place the milli-equivalent value of chloride ion multiplied by the atomic weight, which is 35.45. Since the valency is 1, so we write valency 1 in the valency area in the denominator. Hence, we get a value at around 638 milligrams. So you can see from the equation of milli-equivalent, we can get the equation of the weight of an element or an ion. Easy, isn't it? In this example, we have a normal saline bottle which contains 500 ml of normal saline, which is 0.9% sodium chloride. That means there is 9 grams of sodium chloride in 1 liter of the solution. So we know millimoles is equal to amount by the molecular weight. And we know the amount is 9 grams, which is 9000 milligrams, divided by the molecular weight of sodium chloride, which is 58.44. So we put their respective values as 9 grams divided by 58.44, 9 grams to be converted to 9000 milligrams, since we are equating in millimoles. So 9000 milligram divided by 58.44 milligrams will give the value 154 millimoles. We know one sodium chloride molecule dissociates into one sodium and one chloride ion. Therefore, 154 millimoles of sodium chloride will give 154 millimoles of sodium ions and 154 millimoles of chloride ions. Now, to convert it into milliequivalents, what we can do is to multiply millimole values with the respective valencies. Hence, we get 154 milliequivalent of sodium chloride will have 154 milliequivalent of sodium ions and 154 milliequivalents of chloride ions. I have a question for you now. We have a 500 ml of a normal saline bottle. Can you tell us how much sodium in milligrams is present in this sodium chloride solution? Come, I will walk you through the solution of this question. We have 0.9% sodium chloride, and we have to find how much sodium chloride is in 1 liter of normal saline. So there is 9 grams of sodium chloride per liter. The molecular weight of sodium chloride is 58.44. The molecular weight of sodium is 23. So we know the equation of milliequivalent. So milliequivalent is equal to millimoles into valence. And we further break the equation. Then we find milliequivalent is equal to weight in milligrams divided by the molecular weight in milligrams multiplied by the valence. So we put the values of weight and the molecular weight and the valence. We get 154 milliequivalent of sodium chloride is present in 1 liter of normal saline. Therefore, 154 milliequivalent of sodium chloride will dissociate into 154 milliequivalent of sodium plus 154 milliequivalent of chloride ions. Now that was in 1 liter of the solution, but out here we have 500 ml. So in 500 ml, we'll have half the amount of sodium chloride that's in a liter. So that counts to be 77 milliequivalent of sodium chloride, and 77 milliequivalent of sodium chloride will give 77 milliequivalents of sodium plus 77 milliequivalent of chloride ion. Now we know the equation milliequivalent is equal to weight by molecular weight multiplied by valence. Now we interchange the places to find the weight formula. So the weight is equal to milliequivalent multiplied by the molecular weight and divided by the valence. So weight is equal to 77 milliequivalent of sodium multiplied by the molecular weight of sodium, which is 23, and divided by the valence 1, and we get a value 1771 milligrams of sodium is present in a 500 ml of normal saline. So 500 ml of normal saline has 0.9% sodium chloride, which means it is 1771 milligram of sodium. The requirement of sodium is 1 milliequivalent per kg per day, and the requirement of potassium is 1 milliequivalent per kg per day. Let us now convert the milliequivalent to milligrams. We know that weight is equal to milliequivalent into molecular weight by valence. So we replace those values. The milliequivalent is 1 multiplied by the molecular weight, which is the atomic weight of sodium, is 23, divided by the valence. And we can say now that sodium requirement per day is 23 milligram per kg per day. Similarly, in the case of potassium, which is also 1 milliequivalent per kg per day, we place the values 1 milliequivalent multiplied by the atomic weight of potassium, which is 39, divided by the valence, we get the milligram value of 39 milligram. So we can say The requirement of potassium per day is 39 milligram per kg per day. So, the daily maintenance summary can be updated in this way. 30 ml water per kg per day, 23 milligram per kg per day for sodium, potassium is 39 milligram per kg per day, and dextrose 100 grams per day. 1 milliequivalent per kg per day of sodium is needed, and that is served by 4 grams of sodium chloride. Now let's see. A 70 kilo man will require 1 milliequivalent of sodium per kg per day. So he will be requiring 70 milliequivalents of sodium per day. We know 1 milliequivalent of sodium will dissociate into 1 milliequivalent of sodium plus 1 milliequivalent of chloride ion. So 70 milliequivalent of sodium chloride will dissociate into 70 milliequivalent of sodium and 70 milliequivalent of chloride ion. We know the molecular weight of chlorine is 35.453, molecular weight of sodium is 22.989. So we use the weight formula now. Replace those values. The weight will be 70 multiplied 58.5, which is the molecular weight of sodium chloride. We get a value 4000 milligrams. So that is the reason 4 grams of salt will give us sodium of value 1 milliequivalent per kg per day. This applies to a man weighing around 70 kg. Sodium bicarbonate injections are sometimes used to correct metabolic acidosis. We have a patient, Mr. Bakshi, who weighs 70 kilograms. Mr. Bakshi needs sodium bicarbonate 5 milliequivalent per kg per 8 hours. You have sodium bicarbonate 4.2% 5 ml ampules. Now the question is, how much ml of sodium bicarbonate are you going to load in the infusion bottle over 8 hours? That means how much sodium bicarbonate you're going to load or give in 8 hours to Mr. Bakshi. The clue is the molecular weight of sodium bicarbonate is 84. In order to approach this question, find his requirement of sodium bicarbonate based on milliequivalent. Find the quantity of sodium bicarbonate in milligram in 1 ml. Then find the quantity of sodium bicarbonate in milliequivalent in 1 ml. Now let's do these 3 steps. His weight is 70 kilograms. He will be requiring 5 milliequivalent per kg. So we multiply 5 with 70 his weight, and which comes out to be 350 milliequivalent per 8 hour. Now let's go and find the second point. That is, we need to find sodium bicarbonate in milligrams per ml of the bottle. We have 4.2% 5 ml ampule, right? So 4.2 multiplied by 10 is equal to 42 grams of sodium bicarbonate in 1 liter solution, which means we have 42,000 milligram sodium bicarbonate in 1000 ml solution. That means we have 42 milligrams of sodium bicarbonate in 1 ml of the solution. So we got the answer to the second point also, that is 42 milligram is there in every ml of this solution. Now let's find the third point. Find the quantity of sodium bicarbonate in milliequivalent in 1 ml. We got the value in milligrams per ml. Now we will convert the value of milligrams to milliequivalents in 1 ml. 42 milligrams sodium bicarbonate in 1 ml solution, which means we have to use the milliequivalent equation. Milliequivalent is equal to weight by molecular weight multiplied by the valence, and from there we get the value easily. We put the weight as 42 milligram multiplied by the valence of sodium bicarbonate molecule, which is 1, and divide it by the molecular weight. We get 0.5 milliequivalent of sodium bicarbonate per ml of the solution. So we got the third point cleared. we need to give 350 milliequivalents total in over 8 hours, and the solution has 42 milligram sodium bicarbonate per ml, which means it has 0.5 milliequivalent sodium bicarbonate per ml. Now, each ml is equal to 0.5 milliequivalent sodium bicarbonate. That means he will need 350 milliequivalent of sodium bicarbonate per 8 hour. So, we divide 350 ml of the liquid by 0.5, which means 700 ml of sodium bicarbonate needs to be given in 8 hours. So, you should load 700 ml of sodium bicarbonate into the infusion bottle and set it over 8 hours. Let's have a quick recap of what we studied. Just a brief summary. Mole is a measure of quantity, that is the number of ions or molecules or atoms that are there in a solution. Mole is equal to total weight of the substance in grams divided by the weight of 1 mole of the substance. Whereas equivalent is a measure of quantity and the charge, that is the valence. So remember the formula: equivalence is equal to moles into valence. Mole is equal to total weight of the substance in grams divided by the weight of 1 mole of the substance. 1 mole means molecular weight. Equivalence is equal to moles multiplied by the valence. So equivalence is equal to weight divided by the molecular weight multiplied by the valence. Here are 5 multiple choice questions for you to solve for free. Please click the link below in the description box. You will be redirected to a Google form where you will be asked 5 questions. Select only one answer for each question. Each question will carry 5 marks. Trust me, if you can solve these questions, your concepts on moles and equivalence will be very solid and concrete. If you score 15 out of the 25 maximum marks, you will qualify for the next part of the video on IV fluids. Thanks for watching. Please like, comment, share, and do subscribe to my channel. Click the bell icon in order to get updates about further videos that I'm going to post for you.